name is Dan Solano. I'm from the College of New Jersey, and I'll be giving a presentation on a program I developed as an independent study last semester. The title is Binary Star Modeling and Light Curve Generation, but what I'm really going to be doing is showing a live demo and also a light curve fit to an eclipsing binary star system TU Muscae. And I'm going to show that after I just demo the program. So we're going to do that right now. Alright, this is what happens when you open the program. It also doubles as a hypnosis device. If you want, let me just resize everything so it fits on the projector. Now this is not an eclipsing binary system, but you do have two stars that are rotating in a non-elliptical orbit. And one of the first things you could do is you can change the inclination of the stars, which I'm doing now. So now you see they eclipse each other. I'm going to zoom in a little bit actually. You can see them eclipse each other. You're going to see a little effect right here. That's a parallax effect because I don't actually have a zoom function. I just moved the camera closer to the stars. So you see some effects right here as the star seems to go through, but that's not actually happening when calculating the light curve. And obviously getting into the nitty gritty, I'm going to do a light curve down here because that's what the program is designed to do. We'll go around a couple times and you see right here, this is a plot of the light curve. And essentially what you would see if you were to look at this star is, I mean, you obviously can't see two stars rotating around each other, but what you see is it seems like a star that has variable intensity and that dips. And this is essentially modeling that. And there are multiple effects, and one of which I'm going to change the colors around. You can actually change the temperature at will, and it changes the colors of the stars. And this is based on a Planckian distribution. The hotter the star is, the more it moves through the visible spectrum towards the purple. So to make this one really, really hot, you'll see it becomes purple. You can kind of see that, but that's cool. Now I'll bring them closer together. And then I'm going to generate one more light curve real quick so I can, you can actually have multiple light curves on the screen, but I want to contrast some effects. So you let them go around. You have this red light curve here. I mean, it's no different. One of the effects I want to show is called the ellipsoidal effect. And this is a consequence of the changing geometry as the stars get larger. Once you add in the extra gravity of the second star, you get a distorted shape, which I'll show you. They're not circular anymore. As you can see, as you make them bigger, they become roughly teardrop shaped. I'll move them around a little bit. They're not perfectly circular in their teardrop. And what happens is, I'm pointing right here, if you pull out the surface of the star, which is more or less what's happening, you essentially see this part of the star, you see it much more directly than if it was tucked away and the star was spherical. And what that does is it creates a more well-defined peak in the light curve, because in this position right here, the star system is much brighter, but as they rotate around, this lobe that pulls out right here, it gets hidden by the other star. And it's best just shown. I'm going to show that real quick. Here, the green one is the ellipsoidal effect. And as you can see, this is more what you would expect to see if you were looking at a light curve, where it comes up and it has that peak and then it goes down. And another effect that I have modeled in this program, which is a consequence of the stellar atmosphere, is called limb darkening, which I will add some limb darkening right now. Wow. Now, I mean, when I say limb darkening, you could say, oh wow, that's yellow. That doesn't seem like it's darker. But I mean, the color scheme I'm using is a Planckian scheme where, I mean, technically you're looking at this, orange right here. Here, I'll change the temperature so it's more apparent. You have this blue right here, and that's much hotter, and the light coming from this is more intense. And here it seems like it's brighter, but it's actually not. It's just the color scheme that I'm using. And I'll bring those back to where they were before. And that effect generally has effects down here at the valley of the eclipse. It will lower it or raise it depending on the intensity of the effect. But one thing I did want to show you before I ended was an actual star system, so you could see what it might look like using the program that I developed. And I'm going to basically show you TU Muscae. All right, and just give me 1 second. I have to plug in a couple of values here. You'll see it in a second, I promise. as you can see, I mean, they're basically, they're just touching. It's a close contact binary system with the stars just touch. I do need to change the temperatures though to get an accurate light curve. And this data that I'm putting in, this is from a paper by Dr. Dirk Terrell at the Southwest Research Institute in Boulder, Colorado, that actually wrote a paper about this star system that has temperatures and the inclination. So I'm using his actual data that he published, and I'm going to do a light fit. And one thing that you can actually do, which I just did, I don't know if you can see that, I have his actual data. I actually emailed him and asked for it, and he sent me the data file, the observational data in the ultraviolet of the star system. And what that allows you to do with this program is you can match it because it will plot the light curve there. Now I'm going to change you can change the wavelength to bandpass that you want. I'm going to change that to the ultraviolet real quick, and then I'm going to generate a light curve just to show you one fit. Oh, I actually forgot one effect. I'm going to show this real quick. Let me make this one smaller. This is called the reflection effect. This is a very strange effect, but what happens as these stars get closer together, there's a mutual heating of the star surfaces on the near side. And I'm going to show you, just don't pay attention to the little red one. That one's not very important right now. It's going to be a gradient, and I will show you right now. You see that? You see how it changed to blue? And as it goes around, you'll see it disappears, but essentially the stars mutually heat each other, and it causes a temperature gradient across the star where it's much hotter where they're closer, and and not so hot over here. And that's just one other effect that's built in. I'm not going to show that in the light curve though, because I only have it a couple minutes. And I'm just going to get them back to where they were. I'm just tweaking some of the settings to get it to the fit that I want it to be at. All right, now I'm going to generate a light curve real quick, and I'm just going to show you a fit that you can get using this program that I developed. You can see it right here as it goes along. I mean, this isn't perfect. These are pretty close to the actual values I use, but the magician never reveals his secret. So this is an actual light curve fit, and this is the main thing that you can do with the program is you can keep trying and changing the values, and then you can actually discern properties about the stars based solely on the light curve that you see. And this is the actual light curve fit that I have using Terrell's data and using my program. I plot them both on an Excel file, which you can generate with the program. And essentially one is just the flux normalized to a specific value. It makes it look nice, you can see it, but the actual flux isn't really one, but you can just normalize it to that. All right, these are my sources that I made using the program. Are there any questions?
Well, that was pretty cool. I imagine there's at least one question. So let's just do one question for now, Stan, since you were on the ball. And then if you have any more questions for Dan, we can do.
Or if anybody else wants to.
You can talk to Dan during lunch if you want.
So another effect that you have is when the gravity is weakened, you get what's called gravity darkening.
I have that effect, but essentially what I have is an equal areas approximation that you can turn on and off. When you turn it on, there are less points at the poles, and when you turn it off, there are more points at the poles. So I don't actually have like a changing parameter for the effect, but depending on how you choose to distribute the points, you can have it much brighter at the poles or more evened out. But I am aware of that effect, but I wasn't able to program the changing parameters of that effect explicitly.
Maybe we could talk about it because it's quite an interesting effect in many contexts.
Yeah.
All right, let's give Dan another hand. And I can hear stomachs rolling, so we'll do one more talk before lunch.